Last example. Find the standard error of the mean, 99% confidence interval, and 95% confidence interval for the following set of exam scores. So, now we know that we need to find the standard error of the mean. So let's look at our formula list and see which formula we need to use. Now, in the problem, the standard deviation is not given, so this is the formula that we are going to use. So let's go ahead and write that down here at the bottom. Standard error of the mean. Okay. All right, so in order to get this, we need the sum of squares, we need our n value, and we need a mean. Okay, so our n value, that's easy. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That is how many people are in our sample. Okay, so let's go ahead and calculate our mean. So the mean so the EX is the summation of X, so that is adding up all the raw scores. So we're going to add all of these scores up, and then we're going to divide them by how many we have. So we already know that our n value is 10. So when you add all of these together, you add 10, 9.7, 5.1, all the way down to the bottom, you are going to get 75.6. Okay? And then when you divide that by 10, that will give you 7.56. Okay, so there is our mean, 7.56. Okay, now we need to square each of these and add them up. So 10 squared is 100, 9.7 is 94.09. 5.1 squared is 26.01. 6 squared is 36. Okay, so now that all of those are squared, in order to get this value here, we need to add all of those numbers up. So when you add those up, that is going to give you 603.98. Okay, now we have everything that we need to solve for the standard error of the mean. So let's go ahead and get rid of this, so we have a little bit more room. Okay, so all that we need to do now is just plug the numbers into the equation over here. So we have 603.98 over our n value of 10 minus our mean squared, which is 7.56 squared, over our n value of 10 minus 1. Okay, there we go. Okay, so let's start with this first. So 603.98 divided by 10 is going to give you 60.40, and that's after I've rounded. And then 7.56 squared will give you 57.15, and once again that is rounded. Over 10 minus 1 is 9. Okay, so 60.40 minus 57.15 is going to give you 3.25 over 9. Divide that out, that is going to give you 0.36. And then solve for that square root, and that is going to give you 0.6. So our standard error of the mean, 0.6. Okay, let's go ahead and get to work on finding the confidence intervals. Now we have a 99 and a 95% confidence interval that we need to find. So let's go ahead and pull out our sheet of formula. Okay, and we've got our formula right here for our confidence interval. So let's go ahead and write those down. So we have a plus or minus t of 0.05. That's going to be for the 95% confidence interval. And that is multiplied by the standard error of the mean plus the mean. And then for the 99% confidence interval, we have the same thing, just with the 0.01 value. Standard error of the mean plus the mean. Now, an easy way to remember this is the 0.05 value is always going to be with the 95% confidence interval. So 95 plus 5 is 100. And you can do the same with the 99. So 99 plus 1 is 100. So that's just a little easy way to remember which one you're looking for. Okay, so in order to find these values here, we are going to need to find our degrees of freedom. So the formula for degrees of freedom for standard error of the mean is n minus 1. So if we look up here, our n value is 10. So when you subtract 1 from 10, you are left with 9. So 9 is going to be our degrees of freedom value. So go ahead and pull up your table. This is the level of significance for two-tail test table. I think in your textbook there's also table C. So what we're going to do is we are going to look over here on the left for degrees of freedom and go down to 9. And there are going to be two values. Here is the 0.05 value. So let's just go ahead and make a note of that. So the 0.05 value is 2.262, okay? And then just go to the right of that, and the 0.01 value is 3.250. Okay, and those are our critical values. So now all that we have to do is plug those numbers into the equation and solve. So let's go ahead and get started on this one here. So we are going to plug this number in here. This is your critical value. We're going to plug that in for this right here. So if we're starting with the 0.05, that is 2.262 times the standard error of the mean, which is 0.6, plus our mean of 7.56. Okay, now if you notice here, there's a plus and a minus sign. That means that we are going to have to do this problem twice. Once with this value being a positive, and then once with this value being a negative. So let's go ahead and get started on that. So we'll have 2.262. And remember to copy this number directly from the table, whether it's 3 numbers, 4 numbers, 5 numbers, 2 numbers. Copy what it says from the table and then use that in your equation and round later. And then we're going to multiply that by 0.6 plus 7.56. So first you are going to multiply these, and then when we multiply those together, that is going to give us 1.3572. So we need to round that. That's going to give us 1.36. Okay, so then it's going to be 1.36 plus 7.56, which is our mean here. And that is going to give us 8.92 as our first value. Okay, so we just go ahead and do the problem again, just as a negative value. So negative 2.262 times 0.6 plus 7.56. Okay, multiply these first. That's going to give us a negative 1.36 plus 7.56, and then that is going to give us a value of 6.2. Okay, so our confidence intervals for the 95% are going to be between 6.2 and 8.92. There is that, and that is our 95% confidence interval. Okay, so for finding the 99% confidence interval, we are going to do exactly what we just did. We are just going to use this value here. So we are going to plug this value here into this right here. So we are going to have a plus or minus 3.250 times our standard error of the mean, which is 0.6, plus our mean of 7.56. Okay, so for the first problem, let's go ahead and do the positive number. So we will do 3.250 times 0.6 plus 7.56. I'm going to multiply these together first. So when we multiply these two numbers, that is going to give us 1.95 plus 7.56 is going to give us 9.51. Okay, so there's the first one. Now let's do the negative. So negative 3.250 times 0.6 plus 7.56, that's going to give us a negative 1.95 plus 7.56. That is going to give us 5.61. Okay, so for our 99% confidence interval, our ranges are going to be between 5.61 and 9.51. And that is the 99% confidence interval range. Okay, congratulations. You just did the standard error, the mean, and confidence intervals. Good job.